It's the giant among super sports cars. With around 2,000 horsepower, this hypercar from Croatia is more powerful than a tank and extremely fast.
An emotion for this car would be just whoosh.
The sports car is currently in its hot development phase, but its power plant is already unrivaled. Its power is drawn from a socket.
It's full electrical. It pushes you in the seat like a rocket. It's amazing.
The heart of a startup beats in the supercar's production plant. Around 700 specialists manufacture almost all of the prototype's components in-house.
They're just throwing you into fire and you need to deal with it.
The engineers at the fledgling sports car factory use the results of the demanding crash and stress tests to optimize each millimeter of the supercar.
We are perfectionists. We want really to show what is possible, and if you want to show what is possible, you cannot cook with the same water like everybody else.
At the end of 2020, Rimac will start production of an electric vehicle with the most powerful battery, the most stable chassis, and the best performance in the automotive industry. The C2. The fastest electric cars come from what was previously automotive no man's land, Croatia. The hypercar manufactory Rimac Automobili is located just outside the capital city of Zagreb in Sveta Nedelja. Since 2009, top technology for super sports cars from around the world has been created at the company's 11,000 square meter premises. Here, 700 specialists are now also developing the components for the manufacturer's latest model, the C2. The prototype of the C2 is a fully electric GT hypercar, a total of 4 electric motors with an overall output of 1,914 horsepower. Accelerate the electric sports car from 0 to 100 kilometers per hour in less than 2 seconds. The vehicle is automatically governed to a maximum speed of 412 kilometers per hour. The C2 is the second model from the company's young founder, Mate Rimac. A maximum of 150 of the €2 million electric sports cars are to be produced in Sveta Nedelja. Besides its own models, the manufacturer also produces vehicle components for other brands. This extensive in-house production enables even minor component details to be determined individually.
What we are really good at is that we are producing car and also producing the components for the car. And when we do something like that, then you can optimize the whole system. You can optimize the battery for the motor for the gearbox for the battery, and so on. If you can develop all the components in-house, if you have the flexibility and everything, we can really optimize the whole system, you know, the whole car, and all the systems inside of the car could be really optimized.
The manufacturing facility is equally as individual as the C2's parts. Instead of classic assembly lines, autonomous high-tech departments are found here. Virtually all of the prototype's elements are produced on-site at Rimac. 90% of the C2's basic frame is made of the flexible lightweight material carbon. The Croatians produced the hypercar's 200 carbon fiber elements completely using manual labor.
I think that's a specific for us that we do it all in-house. So normally other companies do it carbon fiber outside. So we use carbon fiber to reduce weight. It doesn't rust, it takes more longer, and with composite materials we can produce more advantage material than with normal technology what is used in car industry.
The Croatians have been fine-tuning the individual parts, the design, and the performance of the C2 for the past 4 years. The design engineers have built a total of 16 prototypes and tested them down to the very last bolt. The young company founder's passion for futuristic hypercars began at a very early age.
Our history is a really long one, although it's only 10 years. I was born in Bosnia, where there were no cars where I was born. And then when the war started, we moved to Germany, where there were a lot of cars. And my parents tell me that I was crazy about cars before I could walk or talk. And when I was 18 years old, I bought myself a 1984, 4 years older than myself, BMW 3 Series. And when the gas engine of that car blew up, of that old car, I decided to make it electric and to build it into a race car, to race gas-powered cars, to show that it can be faster than them. Which I did. I broke with that car 5 FIA and Guinness World Records, which was a great learning experience for me, to learn how to build this car and improve it, although everybody was laughing seeing an electric car on the racetrack. I wanted to show that electric cars don't have to be slow, boring, and ugly.
In recent years, the automotive industry has focused increasingly on electromobility. Rimac is therefore very important for Croatia, although the sports car manufacturer's road initially appeared to be a very long one.
Croatia is the European country with the least car industry, no car industry basically. There were no investors, there was no venture capital fund, no government support, so it was really difficult to bring up the company. The first 6-7 years, I never had the money to pay the next salary. The people wanted to throw us out of the facilities, the electricity company came to cut our electricity, and we had no idea what we were doing. None of us had any experience in the car industry, so we had to figure everything out. With no experience, no money. I was 19 years old, so it was a really tough time. But to survive, we started to work for the car industry. We started to develop cars for them, batteries, electronics, and this became our main business, to work for the car industry. Today, after a lot of hard work of many people, we are now almost 700 people producing some of the world's fastest electric cars, the C2, where we want really to push the limits of what is possible. We want to show what can be done. And we are now in a big expansion phase, and hopefully we will also build soon a new factory.
Within 10 years, the garage has been transformed into gigantic factory shops. Today, nobody is laughing about the young visionaries' idealistic ideas. Quite the opposite. Global company groups such as Porsche and Hyundai have now invested 115 million euros in the Croatian sports car manufacturer. This cash is being used to fund the development of technologies and components that are unique within the automotive industry. This enormous carbon fiber framework comes from the company's own gigantic autoclave. The cockpit frame is a crucial key component in the C2's enormous power output. The electric sports car's outer skin conceals the biggest interconnected fully carbon part in the automotive industry. The 200-kilogram monocoque ensures that the C2 prototype is particularly light and extremely stable. In the assembly area, the technicians are now equipping the empty cockpit frame with everything that transforms the C2 into a high-performance car. At first glance, the assembly shop doesn't look like the birthplace of one of the fastest vehicles in the world. Installing the motors still involves real manual work for the technicians. The all-wheel drive vehicle is equipped with 4 electric drives and therefore needs no differential. The advantage is optimal control and a maximum efficiency of 97%. This means that virtually all of the powertrain's energy is transformed into kinetic energy. In comparison, the maximum efficiency of a combustion engine is 45%. An in-house motor production facility is also located at the plant premises.
So this is the rear C2 powertrain with the motor, inverter, and 2-speed gearboxes in the rear. So this is the rear powertrain unit with 1000 kilowatts or 1 megawatt. And this is the front powertrain unit with 400 kilowatts. So they are quite different if you look at them. So the front powertrain has the motors in the middle, the gearboxes on the sides, and then the inverter on the top. In the rear, the gearbox is in the middle. It's actually two two-speed gearboxes in there. So every motor has its own gearbox, but they share the housing, and every gearbox is independent two-speed gearbox. Each motor is a 500 kilowatt, 700 newton meter motor, and the 1 megawatt inverter. So all of these parts are made in the company in different parts and then assembled here.
Each of the prototype's tires is equipped with a separate motor. Together, they generate a torque of 2,300 Newton meters. The C2 draws the energy for its all-wheel drive from a gigantic battery pack with a capacity of 120 kilowatt hours. This is intended to give the Rimacs a range of up to 550 kilometers and to enable it to reach 80% of its rechargeable battery output again in less than 30 minutes during the subsequent charging process. In the assembly shop, the technicians are now installing the 600-kilogram battery pack in the C2's body shell. The rechargeable battery has an enormous output of 1.4 megawatts. This amount of energy can be used to supply an entire single-family home for several days. The entire rechargeable battery unit consists of 6,960 of these small lithium-ion battery cells and is designed so that each accumulator is surrounded by fire-resistant material in a sandwich construction. With a length of around 5 meters, the C2 is bigger and even more luxurious than its predecessor. It is also fitted with a complex sensor system and is set up for Level 4 automated driving according to Rimac. Autonomous driving is currently subdivided into 5 levels. The C2 is therefore at the level prior to full automation. The car can be guided completely by the system, even if obstacles suddenly emerge. However, the driver must be fit to drive. Certain components are produced at a further factory site located 40 kilometers from the main plant. Among other parts, the Croatians fabricate the two-seater's wiring harness here. The Rimac employees assemble each of the 26-kilo looms by hand. The harness consists of a total of 15 different modules that subsequently supply all of the electronic systems with electricity. Step by step, the electricians process the individual cables for the C2's power output, communication, and sensor system to form the next biggest loom. To do this, they seal the lines with cable lugs. A precise construction plan specifies which cables belong together. The workers took around 2 months to produce the wiring harnesses for the first prototypes. This experience enabled them to optimize the assembly of the 2,400 plug connections.
In first 2 experimental prototypes that we did the wiring, we had the wiring harness basically in one piece with some sub-harnesses. And when we installed it in the car, we could actually see what can we optimize, how can we produce the wiring harness faster, how can we produce the wiring harness safer, and what are the limits of usage.
The complete plan of a wiring harness measures 24 square meters. The 3.6 kilometers of cables are drawn on it. Later on, they can withstand up to 2,000 volts and are therefore equipped with special Teflon, which enables them to cope with temperatures of up to 100 degrees Celsius.
When you have a high temperature or very high voltage, you cannot use just regular PVC insulation because it cannot withstand that.
These workers are testing the voltage. This is important because later on, a fault can shut down the entire system and, in the worst case, cause a cable fire. Here, each week, 7 employees produce 3 new wiring harnesses. In the main plant in Sveta Nedelja, the crew has fitted the wiring harness and all of the other components in the vehicle. Later on, these will supply the C2 with its incredible power. The rolling chassis is now drivable. The only thing now missing to complete the hypercar is the outer paneling. During the first few years of the company's history, the Rimac team worked on several electrically powered prototypes, including a race car. In cooperation with legendary racing driver Nobuhiro "Monster" Tajima, they developed a near-series version of the Rimac Concept 1. To complete the e-runner on time, the young design engineers had to work under high pressure. The crew developed, produced, and tested the vehicle in just 4 months. The lack of time was not the only challenge they faced.
There were a lot of challenges, but two ones that I really remember. So first, because it was an existing chassis, we had to package our powertrain, so the dimensions of the chassis didn't allow for the whole powertrain. So we had to make it shorter, and in order to do that, we were designing a very special transmission system. Everybody who looked at it said it will never work, so we basically wanted to make a chain drive, and because of the high transmission ratio, the final sprocket had to be very small and the motor sprocket had to be quite big. So it was a big ratio, and everybody said, like, this is never going to work, this was going to break.
To rule out this risk and to test the e-runner's output, the crew took the race car to a special roller dynamometer in Slovenia. The team didn't have much time left because the e-runner then had to be shipped to the USA immediately to get ready in time for a special race. Back then, the Rimac team wrote automotive history. In 5 seconds, the race car broke through the 200 km/h barrier on the roller dynamometer. The electric car developed an output of around 1,400 horsepower, a result never before achieved by any other electric vehicle.
1 megawatt.
1 megawatt.
1 megawatt. This is a fantastic day. Memorial day.
History books.
History day.
Racing legend Tajima carried out the final track test in person.
You do the first meters, then the first 100 meters, first 1,000 meters. You increase the power gradually, you increase the speed, you increase the pace. But he immediately, jumped into the car, went to the racetrack, and wanted full performance. So first time he was really disappointed. He was like, oh, this car is really slow. But we gave him just a little bit of power, We didn't want to increase immediately because something, you never know what can happen, what can go wrong.
In 2015, the e-runner and Tajima were on the starting line for the first time at one of the most prestigious races in the world, the Pikes Peak International Hill Climb in Colorado. The Japanese accelerated from 0 to 100 kilometers an hour in 2.2 seconds. The hill race is also called the Race to the Clouds because the participants climb around 2,900 meters to the finish line. Tajima, who celebrated his 65th birthday on the day of the race, achieved the best time of 9 minutes 32 seconds. With a top speed of 233 kilometers per hour, he established a new record in the USA at the time. The driver is thrilled by the young Croatian's team spirit.
Fantastic. Exactly my mind and my spirits. So now I am very happy because this is a 100% best partner.
The Rimac racing team exclusively fits electric motors in its race car models. The company's own test driver helps to constantly evolve and perfect them. He is convinced that the electronic powertrain technology will drive the combustion engine from the world's racetracks in the future.
I am still absolutely sure that this is the future of racing. It's so superior to petrol engines that it cannot be measured. You don't have the gear shift, you don't have that noise. You can concentrate to other stuff that's been happening with the car.
The e-runner was created in 4 months. The C2 took the young startup 4 years to develop. The Young Hypercar Manufactory's design department is also located at the company's premises just outside Zagreb. As the C2 is only the Croatian's second model, the team can still play a pivotal role in engineering the DNA of the Rimac hypercars. The design crew from Sveta Nedelja has also retained its startup character.
Our team is really motivated, and the spirit of them is that they want to push the boundaries. Within our team, we are around 15 people, and we cover all the aspects that concern the design, but also the brand. We start with a simple business card, a web page, a simple invitation for an event, all the way to either a component, such like a motor, or the car itself. The people that actually work here are happy to be able to work on different aspects of this project that we are conducting here.
It's clear at first glance that the C2 is different but unmistakable. Its alternative drive technology also poses design challenges. Each of the supercars' features has a specific purpose because the designers work according to the principle of form follows function. Its bulky proportions are by no means accidental either.
We want to show the muscle that there is on each wheel. The C2 is not your typical hypercar, first of all because it's electric, so it has a completely different powertrain and powertrain layout.
In contrast to other hypercars, there is no gigantic engine block in the rear of the C2. Its electric drive is distributed between the vehicle's front and rear ends. The cockpit and also the center of gravity are therefore located precisely in the center of the car. The weight on both axles presses the Rimacs onto the road and therefore ensures better road grip. Its enormous butterfly doors are a combination of scissor and gull wing doors, which don't just look stylish, but above all, they make entering the flat vehicle more comfortable. At the same time, its design DNA immediately gives away the electric sports car's origin. Rimac's signature sweeping lines on both sides culminate in this bar. It is intended to evoke the unmistakable tie that Croatian soldiers wore during the First World War. The word cravat is derived from the French cravate, the politically incorrect pronunciation of Croat, used during the war.
On the cravat there is 3 lamps that actually show which driving status you're in. You can also configure it towards the country of your origin, and you can also show the charging status of the car. Is a very important feature to show also from the outside. Not that you always have to look on your app or go inside to see what the status is. The front is the most important part of the car for the aerodynamics. This is where the aerodynamics start. Here we have 3 air inlets for 3 different radiators and 3 different cooling systems. One is for the battery, which is the most complicated one. One is for the front motors and one is for the front inverters. And all these operate on different temperature ranges. This area is highly optimized to have enough downforce on the front axle, but also enough mass flowing through the systems.
An adaptive wing at the rear of the vehicle supports the aerodynamics concept. It adopts different positions depending on the dynamic load. This maximizes the downforce when cornering. The wing also serves as an air brake to stabilize the vehicle during heavy braking. A 1-to-1 model of the C2 is now making its way into this gigantic wind tunnel. In several hundred test loops, the design engineers test the vehicle's aerodynamics modules here. They are the result of complex calculations and 3D simulations performed by supercomputers. Rimac also boasts its own aerodynamics department.
It's been a really fast trip. You know, we are developing this amazing car from scratch. The process are being running sometimes for the first time, and we are working hard to make the things happen. And when we see the things that we've been seeing thousands of times in the screen, you know, when we see the reality, they happen. First we have all the anxiety, oh my God, will that perform the way we wanted? And then after we say, oh, thank God, perform it. But let's see if everything is okay, if everything it's really good. As I said, it's being fast. The things are happening really fast.
The engineers then compare the results of the computer's aerodynamic simulations with the reality in the wind tunnel. The results only deviate by an average of 2.4% from the calculations. The aerodynamic systems are aimed at improving the hypercar's performance later on. The Rimac's Aerodynamics kit includes 3 active components. Air flaps in the hood press the prototype onto the asphalt and cool the batteries. The adjustable spoilers located at the rear of the super sports car. Depending on its position, it ensures downforce on cornering or stabilizes the vehicle during emergency braking. With its drag coefficient of 0.28 CD, the C2 cuts through the airstream like a sharp knife. Checking the simulations on the real vehicle is important to decide where the startup should invest in accordingly expensive parts for the next prototypes. The aerodynamics modules press the Rimacs onto the asphalt. The vehicle generally lies very flat on the road.
Every hypercar tends to be really low, so you would have to bend really low in order to get your head under the roof. So with these butterfly doors, part of the roof goes up with the door, so you can easier enter into the car.
The car's interior consists almost completely of high-quality ultra suede. Later on, buttons on the dashboard can be used to configure how the C2's power is distributed to the axles accurately to 1%.
You can calibrate the car to your wishes. So you can tune the powertrain, you can tune the grip on the wheels, you can tune how you want the torque vectoring to behave. And this we show exactly with our knobs that we have in interior, and this is a very unique feature that nobody else has.
To design their vehicles as individually as possible, the Croatians manufacture virtually all parts in-house. Components, like the metal rings on the vehicle dynamics controllers, are also made at the plant. Gigantic high-tech milling cutters are used at Rimacs to manufacture complex aluminum components. Over 1,000 different components are produced at 7 automatic stations. One machine costs up to 450,000 euros and is equipped with highly sensitive sensors. This poses a significant business risk for the young company.
Currently, we are still a startup, I would say, between a startup and a serious company. Why a startup? Because we are still growing like crazy, doubling every year. But in the last 2 years, we are not profitable. We are burning investors' money, which is normal for a company in this growth. We were quite unique looking at that as an automotive startup, because everybody else that is now starting or has started in the last years is burning money from the beginning in 15 years. We are not. We were profitable pretty much from the beginning, but the last 2 years we were not. Now the next step for the company is to go from small series production, where we are now, to really large series. So with our own cars, we never want to go into high volume production. We don't want to compete with our customers. Our customers are the big car companies. So as long as we stay at around 100 cars per year, we are not competition for them.
However, the production of high-end components for the automotive industry is growing continuously. The machines can transform raw steel, aluminum, copper, and plastic into precisely adapted components. Each automatic machine is equipped with around 50 different milling heads. At 20,000 revolutions per minute, they turn, mill, drill, and engrave the raw material. The housing for the battery cells is also produced in this department. It is made of a particularly fire-resistant polymer foam that is also used in aerospace. A system sends the construction plan for the battery carrier to the milling cutter. The machine then produces a new battery housing fully automatically with a maximum tolerance of 0.1 millimeters. The new battery housing then proceeds to a measuring station. An employee checks that all dimensions match the construction plan. To do this, the station moves over the polymer foam framework, and a test finger scans each of the holes. Later on, when the batteries are fitted, the housing is seated in a composite fiber sandwich to shield the battery cell's thermal energy from the environment. The battery pack is cooled from beneath by an aluminum plate. So that everything is seated precisely later on, the workers now also measure the battery's heat sink. They run a high-precision 3D scanner over every centimeter of the aluminum frame. The measured data produce a precise 3D model on the PC, which the crew then uses to compare all of the battery pack's individual parts. The higher the energy density of the battery cells, the greater the risk that they might catch fire. The vapors which then occur with cells that contain lithium is toxic, and a fire is very difficult to extinguish. This machine, a CNC cutting system, is used when a new carbon element is produced in the composite production department. It transforms the raw carbon fiber mats into cutting patterns for the individual components. It can cut up to 1.5 meters of the material per second. The automatic CNC machine is therefore up to 6 times faster than a human. The cutting patterns for a new component are stored on a computer. Once the employee has checked the template, the system forwards the information to the machine. It is equipped with a camera and a sharp knife. After it has measured the carbon mat, the machine cuts the blanks from the material. The raw carbon plates have to be stored at -17 degrees Celsius. The mats are coated with a 2-component adhesive consisting of a resin and a hardener that is activated by heat. That's why the employee is now fetching the trimmed raw material from the cooling chamber for further processing. The 25 employees in the carbon processing department line these plastic molds with the pre-cut carbon fiber parts. They are the negative of a vehicle component and are also made at the plant. These workers prepare each mold according to a specific system before they are equipped. Right now, they're preparing the pattern for a rechargeable battery. So that the fibers lie on the molds like a second skin later on, these workers first clean their surface. The men then apply several coats of a chemical mold release agent onto the plastic. The employees need around 3 hours to prepare a mold. In the composite production department, this worker is just fitting the corresponding pre-cut carbon fiber parts into a door lining mold. In technical jargon, this process is also called laminating. Wet lamination is carried out at remats. This means that several layers soaked with a special fluid are pressed onto the molds. The Croatians produce a total of 300 different components using this process.
When we make pieces from carbon fiber, every piece is different. Sometimes we can use 10 layers of the carbon fiber, sometimes just 3. Depends if actual part must be strong or depends if it must be visual. So sometimes we combine many different materials, not just raw carbon fiber. Normal industry use metal sheets. So if you have metal sheets, you have all thickness in the whole product. It's just one thickness of material. So we can put additional plies where we need just additional stiffness on the product just locally on. Then we make it stronger when we need it, and when where we don't need stiffness, we do it less plies.
Once a component has been completely laminated, the workers package it in a plastic sack. They use a hose to extract air and surplus resin from the film. This vacuuming is important for the next production step because the laminated plastic mold is also a baking form at the same time. The carbon blanks are placed into a gigantic oven for curing. There are 2 autoclaves at Rimac. The ovens function similarly to a pressure cooker. The worker first positions the parts on a table. He then connects these hoses to the sack's valves. They generate a vacuum in the plastic sacks during the baking process. Conversely, there's a positive pressure inside the autoclave during the baking process. At up to 300 degrees Celsius, the individual carbon layers are joined firmly together. The autoclave process is one of the most expensive and complex methods for producing composite materials. The next test really hurts the carbon cockpit and the C2 as a whole. The car has to show how safe it is in a crash test. The front frame goes first, but right afterwards, the engineers will crash the prototype, costing around €1 million against the wall. What the supercar is about to experience has been simulated many times before on the computer by the engineers.
The simulation allows the engineers to evaluate the performance of the part system of full vehicle. We don't need to have a design that is so mature to produce one prototype, which is expensive and takes a long time, to test it physically, to see the failures, and then update the design. We can do this in the virtual world. It is way faster and cheaper also. Basically, it allows us to have much more interactions that we would have if we use only prototypes.
The high-end engineers now drive the C2 into the wall at 56 kilometers per hour. The Rimac has to undergo a total of 5 crashes, 2 frontal impacts, 2 side crashes against a mast, and a rear-end collision. The Croatians then take a precise look at all of the damage to compare it with the computer simulations. In Europe, a 5-star system is used to tell consumers how safe a vehicle is. The damage suffered by the cockpit is particularly important.
It's allowed for you to have some intrusion after the crashes inside of the cabin. You're gonna have 5-star cars and you're gonna see intrusion. We don't have. It's like for the frontal crashes, 0 intrusion in the cabin. Rear crash, 0. If you measure the wall of the monocoque, the wall is there in the position. You have only the door is working. The cabin where the driver is, it's completely sound after a high-speed crash. It's perfect. You don't have problems to be inside.
The crash test results help the engineers to continue optimizing their top technology and their hypercar. This not only applies to the complex electronics and the design. The Croatians are also developing suitable materials for the car's spacey interior equipment in their own small upholstery department.
We're still looking for suppliers. We had 2, but we're currently negotiating with 4 others. We haven't yet decided specifically who's going to be our key supplier. Based on our efforts, we can say that the quality of the products on the automotive leather market is sometimes inadequate. There are a few high-quality tanneries around the world, and we're doing our best to contact the best one.
The saddlers need 5 hides or 30 square meters of material for a complete interior, because the C2 will also be available in a vegan version. The interior designers are only interested in top quality leathers. One hide costs up to 600 euros. The color range encompasses 30 different shades, which the subsequent owners can also combine. In the Rimac Upholstery shop, 3 employees cut, punch, bond, and stitch all of the individual parts for the hypercar's interior. They need 4 days to produce a complete set of interior equipment. The Croatian sports car manufacturer's success story began with the Concept 1, the C2's predecessor. When it started production in 2016, the two-seater was the first electric super sports car and offered the best acceleration of any electric vehicle worldwide. The young design engineers already had the vision of the C2 in their minds, even while they were still developing their first model.
The C1 was always for me just like a step towards the C2, because at the beginning we didn't have the money to do it properly. We didn't, for example, have an autoclave to make big carbon fiber parts. The Concept 1 was a steel chromolybden space frame, it's not a carbon fiber monocoque, those kind of things. We simply didn't have the resources, we didn't have the people, we didn't have the know-how, we didn't have the money. But already then, I think in 2011, we already had the first concepts and sketches and so on. But it took us 10 years to build up a company that can actually do the C2. So it was in my mind from the beginning, that's the car I wanted to build from day one, but we couldn't until now, basically.
To implement their second model, the Rimac entrepreneurs had to restructure their company again.
So we were keeping track of what's happening on the market, of the technology. We were constantly improving the technology on Concept 1 and also on B2B projects that we were doing. And then at one moment we just noticed that it's really time to start building our own car, the new one. So we established a complete team that will be handling just that. And we separated the company from mechanical engineering and electrical engineering to vehicle engineering and the component engineering.
With the C2, Rimac wants to demonstrate once again that electric hypercars are just as good as their combustion engine counterparts in terms of design and performance. To do this, the smart two-seater is put through a series of tough tests. An extensive driving and aerodynamics test takes the visionaries to the northwest of Croatia. On the Grobnik racetrack, the developers take 2 different C2 prototypes to their limits. With 15 curves and a length of around 4 kilometers, this track was the venue for the Yugoslavian Grand Prix as part of the Motorcycling World Championship until 1990. Here, the test drivers can accelerate both of the models up to their top speed. This prototype already has active aerodynamics systems and is equipped with the latest technology. Its blue counterpart is one development stage behind it. The developer's objective is to compare both models with one another to determine how the C2's update behaves on the track. At Rimac, the developers themselves occasionally like to jump into the driver's seat.
When you press the throttle all the way with that car, you actually feel the heat at the back of your head because the blood inside of your head moves to the back of the head. So it's really amazing. You are scared a little bit and you are feeling a little bit uncomfortable, but you're feeling really good because the speed and the acceleration of the car is amazing.
The engineers use the tests to optimize their prototypes down to the last detail. When the design engineers have improved a component, they check it in a stress test. Because these test benches often cost millions of euros, the high-end engineers build their test station using their own equipment. This dynamometer is intended to measure the power of a C2 motor. A Concept 1 drive is used as a resistor for the electric motor. It controls the test unit. The Croatians have strapped both motors firmly to a stable iron frame. The computer then uses sensors to measure the C2 drive's output values. An electric motor functions by outputting electricity from the rechargeable battery to a copper coil, fixed in position in the motor housing. It drives a movable magnet, which is in turn connected to the wheel axle. This leads to propulsion. It is precisely this self-made mentality that makes businessman Mate Rimac sports car manufactory so special.
I never wanted to build electric supercars to save the environment or save the world. Why I made electric cars is because I really believe that electric motor is a much better machine than a combustion engine, the C2. You know, this is a car developed by car enthusiasts, not by hippies. We are not hippies here. I see Rimac as a leader of electric supercars in the future, like the gold standard for high-performance electric cars, and that our components are adding value to many other car companies trying to make good electric cars. It will become like something to be proud of if you have Rimac inside in another car company's car.
So, the most powerful electric sports cars in the world come from Croatia. But Rimac is not only focused on high-end technologies and its own hypercar models. In Sveta Nedelja, authentic visionaries are structuring the future of the automotive industry.